Everybody, my name is Brendan,
I'm Juan.
and today we're going to be going over Code Along 3, Polymorphism.
Yeah.
Woohoo! Okay, awesome. Just a quick recap of what we're going to be going over. To start off, polymorphism. But underneath that, it includes understanding like interfaces and inheritance when you would want to use one over the other, um, how to make a polymorphic method so that one method that, generalizes our code, makes it more generic. Um, and then also some of the benefits and downsides to polymorphism, because there are some caveats when you would want to use one over the other. So we're going to be going through all that. Um, and yeah, so to start, I'm just gonna briefly like set the scene. So what we want to do for this coding along little project is we have this DJ and we want this DJ Lefty, to set up this party and play some music. So to start off, I'm going to do a little quick rundown of all the classes. Um, Starting off with the app class, we have, our normal main function, and in that we're creating a new party. So now I'm going to go over, take a look at party. In party, we're creating, instantiating our new DJ Lefty, and then we're also creating these four objects: Lefty CD player, Lefty iPhone, Lefty radio, and Lefty mic. So now really quickly, we're going to go ahead and take a look at those four classes. Um, Starting off with CD player, it looks like a lot right now, but just know that, we have this general constructor, it's doing some stuff, printing some lines. Um, And then we also have these two methods, plug in and turn on. And plug in is just a print line saying CD player has been plugged in, and then turn on, print line of CD player has been turned on. And so now I'm going to take a look at iPhone. If you see iPhone, a little bit more stuff's going on. But just keep in mind that we also have these two methods called plug in and turn on, saying the same thing, except it's saying iPhone has been plugged in and iPhone hasn't turned on. Um, let's take a look at microphone. A little bit less stuff happening, nothing with play necessarily, but you see once again, plug in, turn on. And then we're going to take a look at radio. For radio, we have this play radio. It's going to take in song name, going to do some extra stuff. But also keep in mind, once again, plug in, turn on these two methods where it's just printing out. Radio has been plugged in and radio has been turned on. So, okay, awesome. So I'm going to start by going back to the party class really quick. Um, and as our to-do alludes to, we have to have DJ Lefty set up some devices. Um, Also really quickly, forgot to look at the DJ class. Let's take a look at that. All right, in our DJ class, we have two important methods: play request and set up device. So going back to the party class, as we said earlier, we want DJ Lefty to set up our device. So we're going to start off with the iPhone, for example. So we're going to call Lefty dot set up device. We're going to pass in Lefty iPhone. Okay, cool. Um, so this is good, but if you see, Java is yelling at us. And the reason why is because we're passing through an argument and it's not expecting it. So if we take a look at our DJ class, as we see, there's nothing necessarily being called, nothing being taken in. So if we want our setup device to take in an iPhone, one thing we could do is pass through an iPhone parameter. So I'm going to go ahead and do that. It'd be iPhone, my iPhone. And I'm gonna preface really quickly that the steps we're going to do, starting with me changing this parameter iPhone, is a bad implementation of having the DJ set up this devices. As we're gonna figure out later on, this becomes a little problematic. It becomes a little repetitive. So, but I'm gonna continue with it. Okay, awesome. So we're setting up our device, passing in an iPhone, and if we remember, in the iPhone class, it has plug in and turn on. So in setup device, we're just going to take in our iPhone parameter, iPhone object, and have it plug in, and then we're going to have it turn. Okay, awesome. So now we're going to go ahead and go back to the party. So we have this lefty iPhone set up. So now we're going to do the same thing with um, our radio. So lefty, that setup device, lefty, radio. Okay, cool. But if we remember, Java's yelling at us because we're passing in a radio when for setup device, we said it was an iPhone. So one thing we could do to um, make this work is to create a separate device in DJ for specifically setting up a radio. So to do that, I'm going to go ahead, go back to DJ and create a new method, public void set up radio. And as we said earlier, it's going to take in a radio called my radio. If we go ahead, look back to radio class, we remember that it also has plugin and turn on. So we're going to repeat the same steps, my radio dot plugin and my radio dot turn on. Okay, awesome. And so this is good, but now we have to go back to party and we're just going to change this to set up radio. Okay, awesome. And now we're going to repeat this one more time, but with a CD player. And as we said earlier, um, we would want to create a separate method because we can't pass in a CD player in the setup radio because that takes in a radio. And we can't pass in a CD player into the setup device because that takes in an iPhone. So what we want to do is create a whole nother method for CD player and have it called setup CD player. But I'm just going to stop really quickly because I want you guys to think how this is problematic. As I said earlier, this is a bad implementation, right? And so I want you guys to pause the video really quick and think why this could become problematic. Okay, great. And so if you haven't already noticed, the reason why this becomes bad is because let's say we have five objects, five devices we want to turn on and plug in. We would need five separate classes. Let's say we had 10. Let's say we had 15. Let's say we had 100. We would need to create 100 methods for DJ just to turn on one of the 100 specific devices, right? And so that becomes really, really bad. So I want you guys to also pause video again and think about how we could make this solution better and how we could set up these devices in a better way using polymorphism. And so I'm going to pass it over to Juan and he's going to show you how.
All right. Thank you, Brendan. Cool. So as Brendan mentioned, our DJ class is getting a little bit too crowded with all these setup blank methods. So when we think about how we can use polymorphism, hence the reason for this code along, we can actually come up with a solution that will make our job a little easier. So I'll give you all like a moment to think about what we could use, and then we'll talk about like some possible solutions. So you could pause and think about it. Okay, cool. So immediately the first thing that comes to mind is, well, maybe we can have an interface and call it like device or deviceable. Um, and then our interface could have the iPhone and the radio and the microphone and the CD player implement like plug in and turn on methods in the interface. And if we remember back at what Andy has taught us about interfaces, we know that they're great for establishing these acts as relationships. So it's good for classes that have the same functionality, but different implementations. So in our case, our iPhone, CD player, and radio and microphone can use an interface if their plugin and turn on methods function differently. But as Brendan mentioned earlier, there's not much that is different about these methods. If we take a look at the CD player, it says CD player has been plugged in. CD player has been turned on. And if we go to the iPhone, we see iPhone has been plugged in. iPhone has been turned on. Um, so these implementations aren't really all that different. And maybe an interface isn't the best solution. If we think what is different about these methods, we can see that they all share one thing in common. They all have some device name that is being put at the beginning of the print statement. So what is another solution that we could use that can maybe take advantage of this, say, attribute? So you, another potential solution is creating a superclass that has the implementations for turn on and plug in, but they also have a property device name that it can use to add to the beginning of this print statement. And this way, we only have plug in and turn on defined in one class, but they all have a shared property device name. So in this case, we'll opt for using inheritance over interfaces. And I can go ahead and do that by creating a new class, and we'll call this device. Great. And for now, we'll make this abstract, and we'll go into more detail on why we choose to use abstract in certain cases. Um, cool. So the first thing that we'll do is create our shared functionality, which is turn on and plug in. Great. And then we also said that the device was going to have a property. This represents a property that all devices share in common, which is a string device name. And so now the only thing that's missing with our property here is to actually define it or to actually instantiate it. And as we know, that takes place in the constructor. So I'll go ahead and start writing the constructor for device. Public device. And then in here, we'll do this dot device name equals. And now we have an issue, or not necessarily an issue, but this can realistically be anything. It can be microphone, it can be radio, or CD player. Um, since we don't know what it should be set to here, we can actually bring this up to a parameter and say that whenever you make a device, you have to give it a name, and that name will become the device name. So we'll do this dot device name equals the name that's passed in as an argument to the constructor. Cool. Now that we have a device name, we can actually implement our methods or define our methods. So here we'll do system.out.print and we'll add what we've already been adding in the other subclasses. And we'll just do this dot device name has been returned. And then in our plugin method, we'll do the same. We'll do system. This dot device name has been plugged. And so now what we've done, we've created a class that acts as a blueprint for all devices. And we're saying all devices have a property device name, and they all know how to turn on, and they all know how to plug in. And so now that we have this new superclass, I'm going to pass it back to Brendan to actually put it to use and solve our redundancy issue.
Awesome. Thank you, Juan. Okay, so as Juan amazingly did, we now have this device superclass that has this generic turn on and generic plug in two methods. So now we got to figure out how to take our four devices and have them inherit, hence inheritance, some of the methods and properties that device has. So we're going to start off by making our way over to the CD player. And I want you guys to really quickly remember um, the terminology or the keyword we need to write um, right next to public class CD player. Okay, cool. And if you guys haven't remembered, it is extends. So because we're extending some of the functionality and capabilities of device to CD player. So public class CD player extends device. Okay, awesome. So if you can see, if you look at the constructor for CD player, Java's a little angry. So I want you guys to think about why this could be the case. Um, okay. And if you haven't maybe figured it out already, it's because we're not calling super. So always remember whenever you're in the subclass and trying to extend it to the superclass, you want to call super in the constructor. So we're going to go ahead, make sure we do that. Okay. Okay, cool. But if you see, once again, Java's a little bit angry. And the reason why is because super takes in an argument. Why, you may ask? Well, if we remember, in the device class, in the device superclass, its constructor takes in a string parameter. So, and the reason why that's the case is because we're initializing our device name instance variable to that argument, to this name parameter. And then we need that when we call turn on and plug in. So in other words, we really need uh, to take in an argument, to take in a string. So going to our CD player, we would want to pass in a string. So in this case, we would want to pass in CD player. And just to remind what this does, when super's called, it's basically calling on the constructor of device. And as we said earlier, device takes in a string name and initializes our device name instance variable to that argument so that when turn on is called and plug in is called, this basically turned into CD player or iPhone or microphone or radio. And that's just a really important thing to keep in mind when you're extending your subclasses. Okay, great. And so now, if we remember, because CD player extends device, it inherits plugin and turn on from the device superclass. So we don't need these two methods anymore. So we can go ahead and easily delete. Okay, cool. And so now we can go ahead and continue this with all of the other devices. So we're going to go over to iPhone. Once again, we want to extend device. And you can see Java is angry at the constructor. And this is a little bit different because for iPhone, it has this instance variable called battery life, and it's setting that to 100. So in this case, instead of calling super below battery life, we want to call it first because we want the constructor of device to be called first thing before we try to do anything else with the class. So in this case, it'd be super, we're going to pass in iPhone. And that's the important thing to remember, that super should always be called first thing in the constructor of a subclass. Okay, great. And then once again, we can go ahead, delete plugin and delete turn on because, as we said earlier, iPhone inherits those methods from device. Cool. All right, we're going to go ahead to microphone, repeat the same thing, extends device, go into the constructor, super, and pass through mic. Okay, cool. And then last but not least, we're going to go over to radio, have it extend um, device, constructor, upset, and super. Cool. And then we're going to get rid of the turn on and plug in methods. Just going to make sure that we did that. Oh, okay. We forgot to do that for microphone. Always remember to do so. Okay. So just to recap, we have our device superclass. And now for CD player extends that device and will inherit plug in and turn on. We're calling super. Same thing with iPhone, same thing with microphone, and same thing with radio. And so you can see that now all these three classes, it looks a lot more condensed, right? There's not as much code, repeated code between the four devices. And so that's the whole point of or one really perk of inheritance is that you don't have to repeat shared um methods that are like very, very similar. And so now I'm going to pass over to Juan, who's going to talk about the importance of using an abstract class.
Thank you. Yeah, so in our case, we made device an abstract class, and not the regular class. And that's because whenever we, in our program, create a device, we want this class to represent or act more like a blueprint than as an actual object. And a good example at why this might be. For example, if you go into a department store like Walmart or something, and then you go into the electronics section, you'll find iPhones, you'll find TVs, you'll find radios, you'll find cameras, but you're never going to find electronic because they're all electronics. So here, device represents more of a classification, an abstract concept. And so this is why whenever we talk about inheritance, we emphasize the is a relationship. So these are all devices. Another reason for making this abstract is because in our code, and this is just a design choice on our end, we never want to call new device. We never want someone to make new device. If there is going to be some device that exists out there, it should have its own class and it should be assigning a name. So in our program, the only devices that exist are iPhone, microphone, and radio. And so whenever anyone and CD player. And whenever anyone wants to create a new device, they'll have to create a new class and extend the blueprint class or the superclass device that will dictate what the device can do and what properties define the device. And so, yeah, so that's a bit of a spiel on why abstract in this case. And the next thing we could do with device is write our polymorphic method in the DJ class. So our issue was that we were going to have a lot of repeated methods for each individual device. So try to take a moment to write the new polymorphic method on your own, and then Brendan will write it right now.
Okay, awesome. All right. So going back to, the very beginning of this code along when we were trying to, set up our devices. And as we said earlier, we would have to create a method in a DJ class for each device. We'd have to have a setup radio, a setup iPhone, a setup CD player, a setup mic. And so now we have a superclass device, an abstract superclass device. And so one way we can try to generalize it is rather than having iPhone or radio specified in the parameter, we can just have a device. So instead of iPhone, I'm going to put in device, my device. And now I'm going to change this to, instead of my iPhone, I'm going to change this to my device. And then likewise, change this to my device. And so now we no longer need setup radio because we have it generalized for just a device. And then really quickly, I'm just going to explain how this polymorphic method works. Okay, awesome. So now what this does is setup device is going to take in a device, any device. It could be a iPhone, it could be a radio, it could be a CD player, doesn't matter. All this method cares about is that it is a device. And so now when we're calling my device.plugin, my device.turn on, it's just going to go ahead and call the method defined in device, but changed with the device name that we specified for each class. So in iPhone, if you remember, we called super and passed in iPhone. In microphone, if you remember, we passed in mic. And so the whole point, as we said, is that this device is now going to make it generalized and just say, hey, I don't care if your iPhone, microphone, whatever, you're going to plug in and you're going to turn on. And so that's what's going to happen. So, really quickly, if we go back to the party class, now instead of having a specific device, a specific method for each device, we can just have one method called setup the device and pass in all of the four devices that we have. So instead of radio, we can just do instead of setup radio, we can just do setup device, pass in lefty radio, and I'm going to continue that for the rest of the devices. So I'm going to pass through lefty CD player, and I'm going to have DJ Lefty set up lefty mic. Okay, great. And so now I'm just going to quickly run this, see what happens. As a reminder, make sure that you compile in the folder of the assignment itself. So javac.java, go into src, and then Java code along 3 dot. Okay, awesome. So now, as we said earlier, iPhone has been plugged in, iPhone has been turned on, radio has been plugged in, turned on, CD player plugged in, turned on, mic plugged in, turned on. And so this terminal output, right? It would be the same if we were to have these four different methods for, the four different devices. But if we go to DJ class, it is much less code. It is much sleeker. It is cleaner. And so that's the whole point of like polymorphism that we're trying to make, that it might not change the functionality of your code, but it will change the organization, how it looks visually, and um, how other programmers are able to look at your code. And so now I'm going to pass it over to Juan, who is going to help DJ Lefty play some music. We already have all the devices set up, so now we're going to play some music and get this party started.
Ooh, awesome. Thank you, Brandon. So now that our devices are set up, we can call on DJ Lefty's methods, uh, or the other method in the DJ class, which is play request, give it the device, and give it the song request in the party. So let's start with lefty.play request. And let's see, let's give it the iPhone again. Okay. And oh wait, lefty iPhone. That makes sense. And let's give it the song request. Apple. Let's see. All right. But we have an issue because here we're passing in two arguments into the play request method. But if we go into the DJ class and look at play request, there's zero parameters specified. So first one I'll leave blank. And the second one is a string. So here is the type that we would put for what we want the object that is passed in to be. And so in the party class, we're passing in an iPhone. So we can just make this iPhone. But we've seen this issue before. If in this method we do like player.play iPhone and then we pass in the song request. If we wanted to reuse this method for all the other devices in the party, we're not going to be able to because we've already constrained it to only accept iPhones as an argument. So I want us to take another moment to think about how can we, again, take advantage of polymorphism so that we're able to play requests from the iPhone, the CD player, and the radio. And in thinking about your answer, something I want you to think about is, should the microphone also play music or accept song requests? All right, cool. So in the DJ class, there are a couple solutions that we could use. So we can The first one being we have all the play requests on iPhone, play requests on CD player, play requests on radio methods, but that can get very crowded very quickly. Another thing we could do is we just made a device superclass. Why don't we take advantage of that? Um, However, the device superclass doesn't have the functionality of playing a song. It only knows how to plug in and turn on. And a solution that we could do is we could define a method called play music. But in our example, we don't necessarily want every device to play music. And this is because if we look at the microphone, it shouldn't be able to play music. Or we might have other classes like toaster or yeah, like toaster or blender, and they might extend device because devices can plug in and turn on, but those devices wouldn't be able to play music. So going back to the DJ class, you can think about a different solution. So we can use polymorphism again to create a new type that will represent anything that can play music. And so maybe one solution is another superclass, but if we look at the CD player and the iPhone and the radio, all their play music methods have very different implementations. So maybe a superclass wouldn't be the best idea here, just because there isn't that much shared code that we could factor out, because they all have individual implementations, right? So instead, what we can do is we can create an interface, and an interface playable can represent a contract for all classes that should be able to play music. And so we'll define one method here, public void play music, that takes in a song string. And so now anything that it implements the playable interface will be able to play music, but they're all going to do it in separate ways, which is already what we have in the iPhone and radio and CD player class. But now we're writing it down in a contract in the interface. So now Brendan will walk us through how we can use this new interface and come up with a polymorphic solution to our problem.
So, okay, Bernie. So as Juan amazingly did, he created a playable interface, right? And for playable interface, we have this declared method. We're not defining it. Remember, interfaces, you don't define a method. You're just declaring it. You're just saying there's going to be some method called play music that takes in a string song. We don't care how whoever implements it does it. It's just going to do so. So I'm going to start off by um, going to our CD player and try to have that implement our playable interface. So I want you guys to think about the special keyword that we need whenever we're trying to implement an interface. Now, well, I kind of just gave it away, but if you said implements, you would be correct. So public class CD player extends device and then implements label. Okay, cool. So if you can see, Java's yelling at us, and that's because we did not um, adhere to the interface contract. In other words, we didn't define and write out the play music um, method. And so always important thing to remember, whenever you have a class that is implementing an interface, it's almost like you're signing a contract with the interface. And like part of that contract, you have to define what these methods are. So we have to define what play music does. And so to do so, I'm going to go back to CD player and we're going to take a look at some of the methods. So if you take a look and see, we have play CD player and then we have wipe CD. Um, and so rather than having to create a new a play music class and then like repeating all of this code, we're just going to go ahead and change this name from play CD player to play music, the generalized play music. Play music. Okay, awesome. And so now the CD player class is happy, but we're forgetting one important thing. Whenever we um, are implementing or defining a class from the interface, oh, sorry, not a class, a method from the interface, we need to use the keyword override to tell Java that, hey, play music, this is from the interface, and now we're defining what goes in it. So always important to do at override before. And then it's also not just a good it not only like tells Java to recognize that this is from the interface, but it's also good just Java practice in general. Like for example, if I'm looking at your code and um, it's I want to know that play music is from something else. It's not from the CD player class itself. It's from play music. It's declared in the playable interface. So always important to do that. And then another thing to note is that for interfaces, you can always implement multiple interfaces. But you can only extend one superclass. Just something to keep in mind as well. Uh, okay, great. So now we're gonna, take with what we did in CD player, and we're gonna repeat that in the other two playable devices. And so those are iPhone and radio. So we're going to take a look at iPhone and we're going to go ahead and have implements. And once again, if we take a look, we see that iPhone does some things a little bit different to play a song, right? So for play iPhone, it first searches some stuff on Spotify and then it prints out playing song from iPhone. It decreases the battery life and then it prints out what the battery life is. Um, If you look up here as a reminder, we have battery life as this instance variable initialized to 100. So as we keep playing iPhone, that battery life decreases. And so kind of continuing with what we did with CD player, to implement the play music, we can just take this and change it to play music. Okay, awesome. And then as a reminder, always make sure to override it because play music is from the playable interface. Okay, so now we're going to go and do it to the radio. Public class radio extends device, implements playable. Yeah. And then once again, Java's upset because we need to um, define the play music uh, method. And so if we take a look at wait, sorry, radio, if we take a look at radio, um, you can see it adjusts the antenna and then it plays the music. And so we're just gonna uh, quickly change this from play radio to play music. Okay, awesome. Um, okay. And so now I will pass it over to Juan to make use of these playable um devices.
Thank you, Ben. So now we have some devices that are devices but are also playables. So now in our DJ class, I want us to think about back to our original problem. What goes here? So kind of already solved this by creating the interface. So we can just plug in playable here. We can see that everything falls into place now, except for this play iPhone call because we've made this method to be play music. And so now anytime the DJ receives a playable, it can play, it can ask it to play music and pass in the song request. And it'll do so differently. And we can see exactly what that looks like if we go into our party class. And now we can see play request passing in the iPhone, nothing changed there. And now we can take advantage of the same method and pass in the radio. We could do lefty radio. Um, and then we'll do single ladies at Beyonce. Great. And now, if we wanted to see what this would look like, we could open up the terminal and we'll recompile our code so that we can run it and see that our songs are being played. Three. Cool. So if we look at our print lines, we'll see that the ones from setting up devices are still there. But now, whenever we call play request and pass in the iPhone, we can see that the individual implementations for each device are being executed properly. So when we pass in the iPhone, it searches on Spotify and then it prints out Playing Apple by Charlie XCX from iPhone and battery now at 99. And when we look at play requests passing in the radio, it prints out adjusting the antenna for the radio. So if we, in the DJ class C, although it's taking in a playable, it's actually executing the individual methods or the unique implementations for each playable. So if it's an iPhone, it knows to call on the iPhone's play music method. And so this is an advantage of using an interface here, is that we have a generic type with unique implementations. There is one drawback to using an interface in this example. In the play request method, we take in a playable. So we've kind of factored out or funneled away any other functionality. So if we pass in an iPhone into the play request method, the DJ only knows to treat the player as a playable. Even though it is an iPhone or it is a radio or a CD player, it can only have the functionality of a playable, which we've said is currently just play music. So we couldn't do something like player dot plug in here, even though that is a functionality of the iPhone because it's a device. So this is something to think about when we explore polymorphic solutions. Uh, it's kind of finding the balance between generic and specificity. So in the party class, for example, we had to declare all these variables as specific types: CD player, iPhone, radio, and microphone. Because if we look at the iPhone, for example, we wanted to pass the iPhone into both the setup device method and the play request method, which takes in a device and playable separately. So if I go here and I change the declared type to be something like playable, this line would still work, and so would the play request call, but setup device no longer works because we factored out all the functionality that is outside of playable. And so now setup device, even though Lefty iPhone is also a device, we've declared it as a playable. So it's good to think about when you would want things to be specific and generic. And yeah, this is it for the code along.
Awesome.
And so now we should all be polymorphic experts.
Yay, thank you so much, guys. Just as a reminder, if you have any questions about polymorphism, feel free to go to conceptual hours, use ADA as well. And feel free to, always look back on this for like guidance alongside all the other code alongs. There will be more code alongs to come, so stay tuned. And yeah, thank you guys so much.
Thank you.